So one of the things that we're going to look at next in regards to functions is some different things with solving different types of equations. So here's an example of one of those types. So we have in the directions, find all real values of x such that f of x equals 0. So just notice here it just says all real values. Because as we've talked about in some previous things, not every equation has real values for x. So in order to solve this, what I want to do is I just want to replace f of x with 0 right here and solve the equation. So when I do that, I get 2x minus 5 equals 0. And then I just want to take this and solve it for x. So I'm going to add 5 to both sides. When I do that, I get 2x equals 5. And then I'm going to divide by 2 at the end, and I get x equals 5 halves. So that's a pretty basic, easy type of equation to look at with something like this. But one of the things I did want to kind of reference with this is when you get to the end of any type of equation, how do you know if you're right? How do we know, other than checking our work here, how do we know if 5 halves really is the answer to this? So I'm going to show you how to use your calculator to do that. So keep in mind with this equation, we know what the value of x is. So what I want to do, or the easiest thing I can do, is I can store that number in for x. So if I type in 5 halves, 5 divided by 2, and I hit the store button here, and then I go to the x key here, push enter. So that'll basically take every time I put an x into the calculator, it will recognize it as being 5 halves or 2.5. And then what I want to do is I just want to type in what the equation says, 2x minus 5. And all of these equations that we're going to look at in this example equal 0. So if I'm right, this should equal 0 right here. So just something you can do when you get to the end of an equation to kind of check your answers there. So moving forward to the second part of this, now we have not a linear equation but a quadratic equation. So I got this, I got x squared plus 7x plus 24 equals 0. So a couple things about quadratic equations. One is, we typically try to solve a quadratic equation by either factoring first or the quadratic formula if something can't be factored. And in order to solve this, in order to solve a quadratic equation, it has to equal 0, which is what this one does here at the end. So we're good with that part of things there. But hopefully you notice just by looking at this that this is not an equation that can be factored. So if you wanted to verify that, remember you can always do the discriminant of the quadratic formula, b squared minus 4ac. I'm just put this off to the side here. And when I do that, when I compute the discriminant, I get 7 squared minus 4 times 1 times 24. And when I compute this, I get negative 47. So a couple things about the value of the discriminant here. One is, because that negative 47 is not a perfect square, that's telling me that this particular equation cannot be factored. That's one thing. But in terms of answering the question to this, if you notice in the directions it says find all real values. One of the other things that the discriminant can also tell you is how many or what type of solutions that a quadratic equation has. So whenever you have a discriminant that is negative, this is going to yield 2 imaginary solutions. So keep this in mind, that when the discriminant equals 0, that means you get 1 real solution. If the discriminant is positive, you get 2 real solutions. So since this question is asking me to find all the real values of x, where f of x equals 0, and this particular equation only has imaginary solutions, what we would say basically to answer this question is that there are no real values of x. that would make this equation equal 0. So that was part B. And then for part C, you know what, let me talk some calculator things with this for a minute. So let me come out of this and we'll talk about how do you know that, from checking it, how do you know it has two imaginary solutions? So what we're going to look at here is the graph of this, x squared plus 7x plus 24. So let me go to y equals. I'm going to put in x squared plus 7x plus 24. And if I zoom 6 this, you'll notice that the graph is not here. And the reason for that is because the window of this, the standard window, really isn't big enough to see the entire graph. So if I zoom out on this, so I'm going to go to zoom, I'm going to hit 3, I'm going to push enter. And if I zoom out, you'll see a parabola type shape, which is what you get from a quadratic equation. And notice that this graph never crosses the x-axis. So whenever you take an equation and you set it equal to 0, graphically speaking, what you're essentially looking to do is, because you're making the y value equal 0, what you're basically looking for, graphically speaking, are the x-intercepts. And you can clearly see here, this graph has no x-intercepts. So because of that, this graph has no real solutions to the
Pam McCluskey, please call
equation.
extension 2316. Pam McCluskey, please call extension 2316. Thanks.
So just moving forward with the next part of this, you have this equation here, 12 minus x squared over 5. So I'm going to do the same thing. I'm going to take the original equation, set it equal to 0. So I got 12 minus x squared divided by 5 equals 0. So what you could do here to solve this is you could either multiply both sides by 5, or you could just put this over 1 and cross multiply, whichever you feel more comfortable with. You're still going to get the same result. So if I just left this over 1 and cross multiplied, if I do 1 times 12 minus x squared, that just ends up being 12 minus x squared. And then if I do 5 times 0, that ends up being 0. So here's sort of the trick here, the shortcut for this, is anytime you have a fraction that equals 0, the value of the fraction that makes the entire thing equal 0 is the numerator. So all you really had to do here was just take the numerator and set it equal to 0, because if the top part of the fraction equals 0, then the whole thing is 0. So in order to solve this equation, I'm going to minus 12 on both sides, so I get negative x squared equals negative 12. And then I'm going to divide both sides by negative 1. I'm going to put this up here now. I'm running out of room at the bottom. So I got x squared equals 12. So in order to solve this, I got to square root both sides. So remember, when you square root both sides, don't forget the plus or minus on this side over here. So this ends up being plus or minus the square root of 12. Which, if you simplify the square root of 12, this ends up being, try that again. So this ends up being plus or minus 2 square root of 3. So once again, how do you know if you're right? Okay, so if I come out of this here, and I go to my calculator here. So let me come back to the calculation screen. And the first thing I want to do is notice there's two answers here. There's positive 2 square root of 3. So I'm going to store that in for x first. I'm going to check that answer, store that in. Oh, let's try that again. 2 square root of 3. Store x. Then I'm going to type in what the equation was. So just a little shortcut here. If you hit alpha and then F1, this y equals, okay, and you go to 1 here, it allows you to just put a fraction in. So I'm going to use that up here. So I got 12 minus x squared over 5. And if I'm right, okay, this should equal 0. But that's not the only answer to this equation. The other answer to this equation was negative 2 square root of 3. So I'm going to store that in for x separately. And then I'm going to type this back in again. I'm just going to push second enter here. And I'll hit it one more time, second enter. That'll get the equation from up here to come back again without having to retype it. And once again, so if I push enter, if I'm right here, it should equal 0, which in fact this does. So just something you can do in your calculator to check your work there. So that's one type of equation we're going to look at today. Another type is this, and that is find the values of x for which f of x equals g of x. So instead of having just one equation and having it equal 0, now we have two equations, and we're going to set them equal to each other and find the values of x. So for part A, I have f of x equals 2x plus 5, g of x equals 3x minus 4. So to solve this, I just want to take 2x plus 5, and I want to set it equal to 3x minus 4. So to solve this, right, I'm going to take the 2x, I'm going to move that over here, which would just make this x. And then I'm going to add 4 to both sides, and I get x equals 9. So there's the equation or there's the answer for the equation for part A. So once again, how do you know if you're right? Okay, so if I come out of this, I'm going to come back to my calculator. Now I'm going to store a 9 in for x. So I got 9, store x here. And then I'm just going to type in both sides of the equation and make sure I get the same values when I do that. So first I'm going to put in 2x plus 5, get an answer. And then I'm going to put in 3x minus 4, which was what was on the other side of the equal sign. And I just want to make sure that these numbers over here are the same when I get to the end. So just something, once again, you can do to check your equations there. So that was part A. For part B, notice now we have a quadratic equation. So I'm still going to do the same thing. I'm still going to take each of the two parts and set them equal to each other. So I got x squared plus x minus 19 equals 3x plus 5. So keep this in mind with, let's try that again. Keep this in mind with a quadratic equation, okay? And that is that in order to solve it by either factoring or the quadratic formula, it has to equal 0. So what I want to do is I want to take both of these terms here on this side, and I'm going to subtract the 3x, and I'm going to subtract the 5. I'm going to move those over so that I'm left with nothing on this side of the equation. So when I do that, I get this. I get x squared. When I minus 3x on both sides, right, I get negative 2x. And when I minus the 5 on both sides, I get negative 24, minus 24. Now it equals 0. Now I can attempt to factor it or use the quadratic formula. So hopefully you can see here, this is a pretty easy factoring kind of question. So when I factor this, I get x minus 6 and x plus 4. So once I factor this now, I want to take each of these parts, I want to set it equal to 0 and solve it. So I'm going to say x minus 6 equals 0, and x plus 4 equals 0. So when I take this first part here, this x minus 6, I'm going to add 6 to both sides, and I get x equals 6. There's one solution. And then with this one here, I'm going to minus 4 on both sides. And when I do that, I get x equals negative 4. There's the other solution. So how do you know if you're right? So I'm going to come back to my calculator again. I'm going to check these answers one at a time. So let me do the positive 6 first. So I'm going to store a 6 in for x. And then I'm going to type in what we had on the left side of the equation, x squared plus x minus 19. Right? And when I get an answer to that, then I also want to type in the 3x plus 5 and just make sure that that value is the same there. Which you can see here, these are the same. So positive 6 is in fact one of the answers. Then let me check the other answer, which was negative 4. So I'm going to do negative 4. I'm going to store that in for x. And I'm going to do the same thing. I'm going to put in x squared. So let me hit just second enter for these. So here's the x squared plus x minus 19. Push enter there. And then I'm going to put in the 3x plus 5. Just make sure that these numbers over here are the same. So once again, just something you can do to check your work there. And then for the last part of this example, notice we have a square root as a part of the equation. So I'm still going to do the same thing. I'm still going to take each of these two parts, the square root of 2x, the plus 3 at the end, and the x minus 1, and I'm going to set them equal to each other. So here's the thing. There's a lot of different ways to do this. And what I would tell you is this problem would be real easy to do if this part right here wasn't a square root and it was just the 2x. So what we want to do first here is we want to try to eliminate that square root from the equation. So what I'm going to do first is I'm going to minus 3 on both sides. I'm going to get this square root part by itself on the left side here. So I got the square root of 2x equals x minus 4. Now that I have the square root by itself, now I can square both sides. And when I do that, I get this over here. I get 2x, the square root and the square are going to cancel each other out. When you take x minus 4 squared, I'm just going to put this off to the side up here. Right? Remember that when you square this, you're actually foiling it. This is x minus 4 times x minus 4. And when you FOIL that, you get x squared minus 8x plus 16. So that's what I'm going to put here, x squared minus 8x plus 16. So just notice with this, it's now an equation that has x squared. It's now a quadratic. So I got to make this thing equal 0 before I can do anything else with it. So I'm going to minus the 2x on both sides next. So when I do that, I get x squared, try this again here, move this up for 1 sec. So if I move the 2x over to the side here, I'm going to get x squared minus 10x plus 16 equals 0. And when I factor this, I'm running out of room here, I'm going to get x minus 8 and x minus 2. Which if I solve these, I'm just going to bring these up here, I'm going to get x equals 8 and I'm going to get x equals 2. So how do I know if I'm right with these? So if I keep these up. So if I go back to my calculator, I'm going to do 8 first. So I'm going to get 8 store x. And first I'm going to type in the square root of 2x. Right, and I got the plus 3 at the end. Get an answer to that. And then I'm going to type in x minus 1. So you can see here they both match. So 8's one of the answers to this. But if I come back to here and I store the 2 in for x, just notice what happens with this. 2 store x. And I'm going to type in the square root of 2x plus 3. And get an answer to that. And then I'm going to type in x minus 1. And notice what happens here. I get 2 different answers here. So what that's telling me is that this value of 2 is not one of the real solutions to this problem. Okay, so this problem here has what's called an extraneous solution. And that's this solution right here, x equals 2. So if you recall from the beginning of this equation in the very beginning, it did not start out as a quadratic equation. There was only, for this equation, it was only intended to have one answer. But through the process of solving this to get rid of the square root, I had to square both sides, which took the equation and turned it into a quadratic equation. So because of that, it mathematically invited a second solution, this x equals 2. A second solution that doesn't really exist. And that kind of solution is what's known as an extraneous solution. And extraneous solutions often occur when you, through the process of solving an equation, you square both sides, which takes an equation that wasn't intended to be a quadratic and turns it into a quadratic. So you invite a second answer that doesn't really exist when you do something like that. So one of the things we're going to look at next here is we're going to talk about the domain of a function, some different things involving domains and equations, and we're also going to take a look at some different things about what's known as a difference quotient. That will be for what we're going to do next.